Okay, so we're going to explain on this video real quick the steps on how to solve using elimination method, aka linear combinations method. And the title is very important because when you say linear combinations, we're going to be combining the lines, right? The top line with the bottom line, we're going to combine them. And the other title, elimination method, that's also very important because our goal is to get either the x's or the y's to eliminate. Okay, so let's look at step one. It says make sure that the equations are all lined up and organized. X's on top of x's, y's on top of y's. That simply means make sure that they're in standard form. So class opener question 3, they are lined up. X's on top of x's, y's on top of y's, and so on and so on. They are both in standard form. Ax plus by equals c. Ax plus by equals c. That was step 1. It's done for us. Let's move on to step 2. What does it say right here for step 2? It says multiply one or both equations by a value so that either an x or a y cancels when you combine the lines. Okay? You may not have to do this step. It might be already done for you. But since we're going to try to do number 3 instead of substitution, I mean, you guys should have done it with substitution, but I want to show you how we could apply these steps to this. If I combine the lines, it's called linear combinations. If I combine the lines, what is x plus 3x?
4x.
4x, okay. What is 4x plus 5, or 4y plus 5y? 9y. So, did something eliminate? No. Okay, let's remember the titles. Linear combinations, okay, I combine the lines, but it's also known as elimination method. Did something eliminate? No. So far that's no good. So let's go back. Let's not do that. Wow, I can't delete. Oh, there it goes. So let me erase that, which I cannot do for some reason. Okay, so it says, step 2, multiply one or both equations by a value so you could get an x or a y to eliminate, to cancel. So we already know that the x's don't cancel, the y's don't cancel. Do you want to cancel, or what do you think is easier to cancel, the x's or the y's? The x's are easier. Now, if you wanted to cancel out the x's, this is a positive 3x down here. What would this have to be up here? It'd have to be a negative 3x. Now, how could you convert a regular 1x to a negative 3x? You multiply it, right? Multiply it by what? By negative 3. So everybody, put parentheses on that top one. Put a negative 3 out there in front of the parenthesis on the whole equation. So what we're doing here is solving it by elimination method. So when I distribute negative 3 times x, negative 3x, and we go negative 3 times positive 4y, that's negative 12y. When we go negative 3 times negative 4, that's equals to positive 12. Now the bottom equation is going to stay exactly the same. I'm just going to rewrite it. 3x plus 5y equals 2. And now it's ready to combine. I put a line right here, and it's kind of like adding, right? You're combining, not necessarily adding, but just you're combining. So what is a negative 3x with a positive 3x? Cancels out, and it eliminates, and that's the title, elimination method. You want either an x to eliminate or a y to eliminate. So on the original one, the x's didn't eliminate. I modified the top equation. Now I am able to eliminate the x's. What about the negative 12y combined with positive 5y? What do I get? Negative 7y. And how about 12 plus 2? 12 plus 2? 14. So, ladies and gentlemen, what do we have here? We have a nice, beautiful, simple one-step equation. Divide by what? Divide by negative 7. And we get y equals negative 2. Ta-da! Wasn't that easy? What about your x? You already have your y. How do you find your x? Plug it in, right? Into any one you want. Let's plug it into the top one. Sure, why not? X plus 4 times y equals negative 4. And of course, we're going to take the y value of negative 2, put it right into the where the y used to be at in parentheses. So I really have x minus 8 equals negative 4. So I go plus 8 here, plus 8 there. X equals positive 4. Ladies and gentlemen, we found the answer, number 3, not with substitution, but we actually found it with the elimination method. 4 comma negative 2. Now, I know you probably, this is the first time you saw it, so you're probably thinking, oh, this is kind of complicated. It gets really easy. It gets really easy, trust me, right? Again, it's called linear combinations. Why? Because you're combining the x's, you're combining them. You're combining the y's. That's why it's called linear combinations. You're combining the top line with the bottom line. But it's also known as elimination method. Why do they also call it elimination method? Because that's your goal. You either want the x's to eliminate or the y's to eliminate. And if they don't, you're going to have to change something to either get the x's or the y's to eliminate. Okay?
Are the x's?
So you just asked, are they always going to be easy to manipulate? Like, let's say this was a 1x, right? Yeah. So you say, oh, what times 1 gives you the opposite of 3, so negative 3 times 1. That one's easy. Now, there's going to be easier ones than this, and there's going to be more challenging ones than this, right? Now, why is that? Because sometimes it'll be ready for you to combine and cancel. Like over here on the actual examples, let's take a look at example number 1. And let's think about the title, linear combinations. If I combine the line, the other title, elimination, will something eliminate? If I combine the lines, will something eliminate?
Wait, so
yeah.
It could be the x or the y?
Yeah, the x or the y. As long as either the x's cancel or the y's cancel. You just want something to eliminate.
Oh, so you call it y draw the line already done?
So number 1 is already done. Check it out. You put a line right there and sas, that's gone.
Oh, I thought you said like that was not the right way to do it.
So what do we have left here? We have 8x equals
20 something.
16.
Yeah.
Now, that's a simple one-step equation, guys. All you do is divide by 8, and you have x equals 2. I mean, that's super easy, right?
So number 3 is the hardest to see.
That's one answer, right? And we didn't even do much. Now, you still need the other answer. What would you do to find the other answer?
Plug it in.
Plug it in. So you would take the 2 value for x and plug it in either the top or the bottom. What do you guys, top? You could go bottom if you want, but I'll go with the top. 5 times 2 minus 6y equals negative 32. So now I'm able to solve this guy. 5 times 2 is 10. Minus 6y equals negative 32. I could get rid of the 10 by doing the opposite of 10. Minus 10. Minus 10. We're going to have a new equation up here that reads negative 6y equals negative 42. So my final step would be to divide by negative 6. Divide by negative 6. A negative divided by a negative is a positive, and yes, positive 7. So your two answers for this top equation is x equals 2, y equals 7. You're going to write it as a coordinate 2 comma 7. Now, that really is way easier. I mean, think about it. If you didn't know this new method, you would have to pick an equation and either get x or y by itself. That's going to be ugly. You're going to end up with fractions. It's going to be messed up. So that's why it's so important that we learn this new method called the elimination method. Linear combinations. You want to combine the lines, but the whole purpose of combining the lines is to either get the x's or the y's to eliminate. If it doesn't happen, you're going to have to modify it. Number 2, do we have to modify that?
Yeah,
No, it's ready to rock. Check it out. Cancels. 3y equals what?
Negative 6.
Negative 6, which means that we already know an answer. What's the answer?
Y equals negative 2.
Y equals negative 2. Easy. Easy peasy lemon squeezy. Yeah, then you just plug it in. So you want to plug it into the top one or the bottom one?
The bottom. Yeah, the bottom.
All right. Ricky says bottom, we're going with top. 7x plus 2 times y, plug in the negative 2 right in there, equals 10. So we're going to have 7x minus 4 equals 10. And plus 4, we're going to get 7x equals 14. Divide by 7 on both sides. And we'll get x equals 2. So your answer for number 2 is 2 comma negative 2. And just like always, guys, when you have an answer and you want to check it, take your x value, plug it into x, take your y value, plug it into y, and you'll see that it really does give you 10 when you do the math. Take your x value of 2, your y value of negative 2. I'll even do this one right here. Negative 7 times 2 negative 14. Negative 14 plus the negative 2. Negative 14 plus negative 2, that is negative 16. So you could double check all your answers. You could guarantee yourself an A+ on Friday's quiz. Okay? Now, of course, not all of them are going to be ready to combine and cancel like this, right? Number 3, if you combine them, nothing cancels.
Is the test just going to be questions like this?
The test is going to consist of a two-sided paper that has a bunch of systems, right? And I say solve them with whatever method you want. Now, some of them are going to be written in y equals mx plus b form. They're going to be ready to graph. It's easy. You could just find the answer by looking at it if you think about the graphing. So it would be pointless to rewrite those in standard form if you already could see the graph and you already see the b values the same, so you know where they cross. Or I might give you one that has y equals already and it's ready for substitution. But on all of them, you could manipulate them to change them into standard form to use elimination method. So if you wanted to use elimination on all of them, you could.
So they're all just find the point?
So it's all just find the point, find the answer, the x and y value. So like on number 1, you could, if you wanted to, subtract 2x, move it over here, and have negative 2x plus y equals 0, and then 6x minus y equals 8, and then think of eliminating them, right? Using the elimination method. But anyway, right here, what would I have to do to get something to eliminate?
Nothing. Oh, yeah, actually, you have to
Multiply
by negative 2.
by -2. That's one option. That is one option. It all depends on whether you want to eliminate x's
Multiply by -1.
or y's. Okay? So if you want to cancel out x's, go for it. Multiply the top one by -2. That way this becomes a -4. That way it'll cancel with the +4 if you want to cancel out x's. Or you could be like, hey, this is a +18. I can make this negative by multiplying the whole thing by -1 down here, right? So the beauty of math is that there's many roads to the same place. You could decide to cancel out x's. Your partner could decide to cancel out y's. It looks like you guys are doing something totally different, and you end up with the same answer if you don't make mistakes, obviously. Again, many roads to the same place. So you could choose to cancel out x's. You could choose to cancel out y's. Because you guys told me to multiply by -2 first, that's the first thing you guys said, I want to go with that. Now, normally I would just multiply the bottom one by -1 and it'd be ready to go. But I want to multiply the top one by -2 just for funsies here. So the top equation becomes -4x, it becomes -36y, and it becomes +18. And that's my new modified top equation. The bottom equation, I'm going to just rewrite it. 4x plus 18y equals -27. So the original one, it wasn't ready to cancel. 2 and 4 is 6. 18 and 18 is 36. That didn't work. After modifying the top one, now I am able to combine and cancel. So these guys combine, the x's cancel, -36 with a +18, that gives me a -18y equals, what is that? -9. Dang, it's ugly. Why? Because to get rid of that -18 in front of the y, I'd have to divide by -18. And I'd get y equals +1/2. You can't really divide 9 by 18. So it is kind of ugly. But let's just go with it. We need to plug that in to either the top or the bottom to find the other answer. Which one do you want to plug it into?
Top.
Sure, why not? Top. So 2x plus 18y, but instead of y, I'm going to plug in this 1/2 equals -9. Now, if you're freaking out right here, oh, I need to multiply 18 by half.
Can't you put a 1 over?
Yeah, you could put a 1 underneath the 18, or you could even do it with the calculator, or you could even think logically. What's half of 18? 9. Yeah, half of 18 is 9, right? I mean, it's really not difficult. You could put it over 1, and then multiply 18 times 1, that's 18. 1 times 2, that's 2. 18 divided by 2, that's 9, right? So let me rewrite everything. 2x plus 9 equals -9. Then what?
You rewrite the thing on the bottom, right? Wait, no, my bad.
You want to solve for x.
-9.
Minus 9. You're going to end up with 2x equals -18. Final step, divide by 2. Divide by 2, x equals negative 9. Ladies and gentlemen, your answer, which could have fractions in it, is negative 9 comma 1/2. Negative 9 comma 1/2. If you were to plug in the negative 9 for x and the 1/2 for y, it will give you a negative 9. If you were to plug in negative 9 right here and the 1/2 right here, it will give you negative 27. And of course, you could verify all this with a calculator. All right, number 4. What do you say?
Multiply the bottom by 5.
Multiply the bottom one by 5. That's a great choice. Now, let's say you were fixated on canceling out x's. What would you have to multiply by to cancel out x's? The bottom one by negative 7, right? So, I mean, when you start looking at all your different paths, like, do you want to multiply everything by negative 7 or do you want to multiply everything by 5? 5 is the easier option, right? So, analyze and decide which one's easier. Let's multiply the bottom one by 5. That way the y's cancel. But like I said, if you decided to cancel out y's and your partner decided to cancel out x's, you can still get to the same answer. So that top equation is going to stay the same. 7x plus 15y equals 32. The bottom one is going to change to 5x minus 15y equaling 5 times 20 is 100. And now we're ready to rock. Now we're able to combine the lines to eliminate the y's. So the 15 and the negative 15, the y's are gone, no more y's. We now have a simple one-step equation. 7 plus 5 is 12. We're talking about x's equals 132. That's right. To get rid of the multiplication of 12, we divide by 12, which means x equals 11. If you're not too sure about that, use a calculator. You have one answer. You need the other. What do? Plug it in. To either one. And let's go with the bottom one since she said bottom. X minus, instead of x, let's put the parenthesis and the 11. Minus 3y equals 20. And as you can see, the parentheses aren't even necessary. There's nothing to multiply by. So you don't even need the parentheses. You could erase those parentheses. So let's solve for y. Let's get rid of that 11 by subtracting 11. Subtracting 11. We're going to have a new equation that reads negative 3y equals positive 9. And of course, we're going to divide by negative 3, divide by negative 3, which means that y equals negative 3. So as an answer, we're going to write it as an ordered pair, 11 comma negative 3. Of course, if you have time left over on the quiz Friday, plug in those x and y values into both equations and double check. Make sure it works out on both equations. That way you could be absolutely positive you got it right. So sometimes it's really easy to use the elimination method because it's ready to eliminate. Sometimes you have to modify one equation like we did right here. But on the steps over here, it says sometimes modify one or both equations. Let me show you one which is like the most challenging one, and you'll see it's not even that challenging. You have to modify both equations. Check it out. Everybody flip your paper over, copy this one down. So if I were to combine the two lines right now, it would not eliminate. The x's would not eliminate and the y's would not eliminate. Okay, so what we need to do is modify both equations this time. So as you can see here, guys, if you combine the 3 with the negative 4x, that's negative 1x, it doesn't cancel. If you combine negative 6x with negative 6y with positive 7y, it's 1y, it doesn't cancel. Again, it's called elimination method because you want either the x's or the y's to eliminate. So you're going to have to modify both equations in this case. So let's ask ourselves, do we want to cancel out the x's or the y's? It's totally up to you. X's. Now, if I wanted to cancel out x's, this has to be a positive value, and this has to be the same value but opposite. It has to be the same number but negative, right? So I need to change this to a 12 and change this to a negative 12, but it's already negative. Yeah, that's what I mean by changing both. So let's do this. Everybody put parentheses around that top equation and put a 4 out there. And let's put this one in parentheses also. And let's put a 3 right there. Everybody do that. Write down those notes. Now, the new top equation will be, well, what's 4 times 3? That's 12. Of course, we're talking about x's, right? 4 times 3 is 12x. 4 times negative 6y, that's negative 24y. 4 times 9, that's 36. So that's my new top equation. My new bottom equation, after multiplying by 3, 3 times negative 4x is negative 12x. 3 times positive 7y is positive 21y. And 3 times negative 16, that's negative 48. And of course, use a calculator if you're questioning it. You see, it was not ready to eliminate x's. Now, after modifying both top and bottom equation, it is ready to eliminate x's. So let's do linear combinations. Let's combine the lines and get the x's to eliminate. So combine the lines, the x's eliminate. We end up with negative 3y equals, what is that, negative 12? And now that's a really simple one-step equation. Divide by negative 3, divide by negative 3, y equals 4. Ta-da! You have one answer, you need the other, plug it back in to the original. So like on the top one, 3x minus 6y, but instead of y I put parentheses, equals 9. And in the y position I put 4 because y equals 4, so I put it right in there. So I end up with 3x minus 24, because 6 times 4 is 24, equals 9. So I need to get rid of that minus 24 by adding 24, and we'll have 3x equaling 33. Which means that our last step is to divide by 3, which means x equals 11. Ordered pair, 11, comma, 4. So that's as hard as it gets when you have to modify both equations. And honestly, it's not that bad. Okay? So this new method of elimination method, it's great. It really makes everything easier. Now, again, on Friday's test, you're going to have a bunch of systems, and you could choose any method you like. You could use elimination, or you could use substitution, right? Obviously, right here on this one, you would not use substitution. It's really difficult. Like if you wanted to get y by itself, you'd have to subtract 3x, then divide everything by 6. You even end up with fractions, and you don't want to be substituting fractions. So elimination is definitely my preferred method of solving any system. Okay, unless, like if I had something like this, let's say I had a system like y equals 1/2 x minus 3, and let's say I had 2y equals x minus 20. Then right there I would choose graphing, because this is already in slope-intercept form, and if I modify the bottom one to get into slope-intercept form, I'll have a new equation on the bottom that reads y equals 1/2 x minus 10. So if you think about this graph and you think about this graph, they both have the same m value, which means that they'd be parallel if I graphed them, which means no solution to the system. Right? So if you already have it set up in y equals mx plus b form, then you might want to think about the graphs. All right, I'm done. Let's work on that worksheet.